Again, good morning, everyone. My name is Dan Brown. I'm one of the senior hurricane specialists at the National Hurricane Center, broadcasting to you from my home this morning in South Florida. We're very happy that everyone could join us for our international series this week of webinars. We've been moving along the U.S. coast from Texas up to Maine over the last several weeks, and we're finishing this week with our international webinars. Did one yesterday in Spanish, and today we have our English version. So again, welcome to the webinar. We have a distinguished panel of guests and experts that you can ask questions to, and I'll introduce those in just everyone in just a moment. But I do want to remind folks that, again, we won't be unmuting anyone. We won't be able to see anybody today, but you do have the opportunity to type in your questions in the question box that you see. We're actually going to ask you a couple of poll questions as well, and there'll be an opportunity to answer those. But again, the question box, we can see that. We'll be typing in some of those answers throughout the webinar, and then we'll save some of those for the end. We hope to save about 20 to maybe 25 minutes today to really have a discussion about what we do and answer those questions that you all send in. So with that, let me go ahead and do the introductions here. First, we'll introduce the hurricanes that have unfortunately impacted a lot of the areas that you may be listening from today. And one thing I was going to ask folks, if when you're typing a question in, or if you just want to say, hi, I'm listening in from whatever country you're in, do that, and we'll try to give a shout out to some of the various places that people are listening from this morning. But as you can see here on this screen, unfortunately, there's been a lot of hurricanes that have impacted both the Caribbean, Canada, Bermuda, and other parts of the Atlantic Basin, in which the Hurricane Center does forecasting and works with many of these fine folks you see on the screen. But some of the recent storms, like Hurricane Dorian, is one that we all remember from last hurricane season. Hurricane Gilbert was way back in 1988, but that was one of the strongest storms on record across the Caribbean. And then you'll see Hurricane Juan, which is impacted Canada, and I bring up Canada because we have someone on from Canada today that's going to help us out. So with that, let me go ahead and introduce our panel of experts. Again, you don't see Robbie on the screen yet because we only can show 6 webcams, but he and I will be turning on and off our webcams and moderating the question and answer later. So Robbie Berg is one of our hurricane specialists at the National Hurricane Center. I'm also joined by Mike Holmes. Mike is a flight meteorologist with NOAA's Aircraft Operations Center. They're the folks, the brave men and women that fly right into the hurricanes and provide that data to us at the National Hurricane Center, a real big vital part of that team when it comes to forecasting and doing what we do. You also hear from John Cangialosi. John's going to take us through the first part of the presentation. He's also one of our hurricane specialists at the National Hurricane Center, and also Andy Latto. He's going to take us through the second part of the presentation. He's also a hurricane specialist at the Hurricane Center. And then I'm also joined by 2 really important individuals that are meteorologists. One is Bob Robichaud from Canada. He is kind of my counterpart up at the Canadian Hurricane Center, and one of their warning preparedness meteorologists up at Canada, and he is also interacting with the public and media and making sure folks are heeding those watches and warnings when there's a hurricane threatening, even if places as far north as Canada. And then I'm also joined by Rohan Brown, and he is a meteorologist from the Jamaican Meteorological Services. And again, happy and excited to have folks on from both the Caribbean and the Atlantic, and we coordinate with these individuals a lot at the Hurricane Center, making sure all these places and residents get those watches and warnings, and we'll talk about how that's done today. So again, thanks for joining us. Seeing a lot of folks typing in people from Belize and Canada online, so the Dominican Republic, so it's great to have everybody on, and I'm going to send it right over to John to get started with the presentation.
Yeah, thanks, Dan. Good morning, everybody. Like Dan mentioned, thanks for joining us. I hope you're excited to learn a little bit about hurricanes today, and you're going to learn that there's a whole bunch of jobs meteorologists can have. But do you know what a meteorologist is? Hopefully you know, a meteorologist is someone who studies or forecasts the weather for their job. And the bottom line for everybody listening today, if you have an interest in math and science, and you have a fascination about the weather, I think you have what it takes to be a future meteorologist. So keep that in mind if everything you hear today sounds pretty interesting to you. And as Dan mentioned, ask all the questions you want today. We'll hope to get to as many as possible. Now, I want to tell you a little bit about our jobs first at the National Hurricane Center. As Dan mentions, greetings from Miami, Florida. Now, I wish we could be at the center today showing you around, but hopefully you still get a sense of what we do there. First, take a look at some of the pictures here. This is the outside of our building. And when you see the building, you might say it's not very pretty or exciting looking. And yeah, I would agree. But if you look close, you'll notice that the building is very, very strong. It's made of concrete and steel. And it's designed that way to keep us safely working in that building, even if a big hurricane comes to South Florida. And as you'll learn coming up, South Florida is very much in a location that sees a lot of hurricanes. Now, our job at the National Hurricane Center is really big, and it goes way beyond just the United States. We forecast hurricanes and tropical storms over the entire Atlantic Ocean, generally from Africa all the way westward, and then into the Pacific Ocean to pretty close to Hawaii. Now, in addition to forecasting hurricanes, we also tell boaters, big ships, and other people who spend time on the ocean what the weather is going to be like. So I don't know if anyone out there likes to go offshore fishing, or maybe some of you have been on a cruise before, or maybe you even know someone that works out to sea. It's really important to keep everyone out on the ocean safe and really protect them against some of the very strong winds and some of the really large waves. And at the National Hurricane Center, we take a part in trying to do that across the tropical and subtropical waters. Now, we also talk to various countries across the Atlantic and Pacific. And that's why we have Bob and Rohan with us today, because we coordinate with those countries, both Canada and Jamaica, all the time. Now, here's how it works. Let's say there's a hurricane approaching your country. The National Hurricane Center would call up your meteorological service or weather service office in your country, and we will work together to put up the right watches and warnings to try to keep all of the residents in those countries safe. And you'll learn more throughout the webinar how all of this works. And on the right is our little cheat sheet that we can actually figure out which phone numbers to call what country. So with that, let's go to one country that we actually talk to quite often, maybe a place that you don't typically think of when it comes to hurricanes. Let's head up to Canada in Nova Scotia and talk to Bob about what the Canadian Hurricane Center does. So Bob, are you there?
Yeah, thanks a lot, John. Yeah, my name is Bob Robichaud, and I'm a warning preparedness meteorologist with the Canadian Hurricane Center. And as John says, you know, we're pretty far north from the tropics, but we still get impacted by these storms. Usually at least a couple a year will either move through our marine territory, or we'll have some sort of an impact on land, as Dorian did last September. So basically, we've been around for over 30 years, and it was a storm called Gloria back in 1985 that really showed us that we needed a hurricane center here in Canada. So we've been operational since about 35 years at this point. So our job is not necessarily to reproduce what they do at the National Hurricane Center in Miami, but we're here to provide more detailed information as it pertains to Canada, so that Canadians can take precautions to protect their lives and their property when we do have one of these storms approaching. So we again, like John says, we work very closely with the National Hurricane Center during the off season on a variety of projects like this, like the session that we're doing now, for example. But we also send some of our forecasters down to Miami for some training, usually in the springtime before the season starts. And of course, during storms, we will coordinate very, very closely. We'll be on the phone several times a day as we track a storm that's approaching Canada. So we don't necessarily issue forecasts on every storm that's in the Atlantic, but as you can see on the slide here, we have what we call a Canadian Hurricane Center response zone. And what we'll do is we'll start issuing our own forecast with details for Canada about 3 days prior to the storm, the center of the storm, entering that response zone. So that's what we do in a nutshell at the Canadian Hurricane Center.
Thank you, Bob. I appreciate that. And I know you have a beautiful facility there in Halifax. Was lucky enough to go visit it and meet some of the staff. All right, let's move away from Canada now and head south to Jamaica. And I know Rohan's in the office, but Rohan, do you have a few minutes to talk to the students about what you do there? All right, don't hear from Rohan. He did mention he is hard. Rohan, are you there?
Sure, and a warm welcome from Kingston, Jamaica. Here at the Met Service in Jamaica, we provide a general forecast every day for 365 days of the year. But when it comes to a hurricane, our system and how we operate, we transform, we change. Now, the manager, who is currently the director, he now becomes a severe hurricane forecaster or a hurricane forecaster or hurricane specialist, and we change our operations. Now for Jamaica, there is a grid, and whenever a system is in that grid, we start to change our operations. We begin to communicate with the National Hurricane Center, our forecasters, plus a severe forecaster, and then we start to coordinate our warnings, prepare our bulletins, and we have that dialogue. Presently, we have about 14 meteorologists, 40 meteorological technicians, and we operate a general forecast, but we shift to severe weather when there is a severe event out there.
Well, thank you, Rohan. And anybody in the Caribbean, I want you to take advantage of asking Rohan some questions at the end. Jamaica is obviously one of the hardest hit countries from hurricanes. And if you live in the Caribbean, I bet you want to pick his brain about all of his Caribbean Sea sort of weather knowledge. So thank you, Rohan. I know you're busy at work, so we'll come back to you later on. All right, let's talk a little bit about hurricane science. And I want you to take a look at this satellite animation here and learn about some of the parts of a hurricane. What you see here is an animation from Hurricane Harvey in 2017 that struck Texas as a Category 4 hurricane. Now, when you look at this animation, what catches your eye? I bet it's this big hole here right in the middle, am I right? That's the eye of the circulation. Now, the eye of the circulation is a weird place in hurricanes because, believe it or not, in the middle of a hurricane, it could be almost completely calm and even sunny, like it's almost a nice day out. But I say it's weird because right outside the eye, in this zone here that I'm circling, is called the eye wall, which is the worst place to be in a hurricane, where the winds are the strongest, the rain is often the heaviest, and where the damage tends to be the worst. Beyond that, in the zones out here are the rain bands, and those are all spiraling around the center. And in the rain bands, the winds can be really gusty, and as you'll learn, there can even be some tornadoes in certain circumstances. Now, I want everybody to just take a big picture look here, and I'm going to try to put it in motion again so you can see it. Just take a big look. Aren't hurricanes, at least from space, almost beautiful? You can kind of say that, but they're certainly not beautiful or amazing if one strikes your area because of the amount of damage and really devastation that they could cause. Now, let's talk about how we group hurricanes. I already mentioned a Category 4. So how does this work? What do these categories mean? Well, decades ago, we had these two men work together. Herb Saffer, who was an engineer, and Robert Simpson, who was a meteorologist, worked together to try to talk about and communicate how strong hurricanes are and how strong they could get. So here's how the scale works. It is only based upon the strength of the winds, only the winds. But as you'll learn, hurricanes bring a lot more with them than just their wind speeds. Anyway, Category 1s have wind speeds between 74 and 95 miles an hour. And as the categories go up, as you see here, the wind speeds get higher. And by the time you get to the top of the scale at Category 5, the wind speeds are tremendously powerful, where they're at least 157 miles per hour. Now, we have another group that we call major hurricanes. You might see that wording here. Major hurricanes are Category 3s, 4s, and 5s. And if you ever hear the Hurricane Center say there's a major hurricane, it means there's a really strong one out there. So let's take a look at where all of these hurricanes go that we know of in history. Each line you see here on the screen shows you all of the tropical storms and hurricanes that we know of all the way back to 1851 in the Atlantic Basin and from 1949 here in the Pacific. And I won't spend too much time on this slide, but the only thing I want you to see is there have been a lot of hurricanes. So take just a second to try to locate where you live on this map. Is your area covered by some of these lines? I bet it is. If you're listening to us today from anywhere across the Caribbean Sea, or much of Central America, or Mexico, or the United States, the Bahamas, Bermuda, Canada, the bottom line is hurricanes have and will affect your area again. So certainly start to pay attention and think about what you would do if a hurricane comes to your area. Are you ready for your quiz? Dan mentioned earlier that we're going to ask you poll questions. So here's your first one. We want to keep you on your toes and test how much you already know about hurricanes. So here's how this works, everybody. After I read this question, a pop-up is going to appear on your screen. What I want you to do is select what you think the correct answer is. Are you ready? Here is your first quiz. When is the Atlantic hurricane season? Do you think the right answer is A, May through November, B, December through April, C, June through November, or do you think it's D, all year long? All right, I see Dan has opened the poll. Good luck, and please vote for what you think the correct answer is.
Thanks, John. Yeah, the poll is open. Hopefully everybody sees the pop-up window that came up that asked that question. Looks like more than half of you have already voted. Give it another few seconds to tally all those votes. Looks like we have a really smart group today, John.
I'm not surprised, Dan.
I think I'll go ahead and close the poll. Most everyone has now voted. I'll see if I can share those results. So about 60% said June through November, and another third said May through November. So about 9 out of 10 said either starts in May or June and goes through November. I'll let you give me the answer, John.
Sure, thanks, Dan. I'm going to say 9 out of 10 got this right. In reality, the correct answer here is C, June through November. Hurricane season's officially June 1st to November 30th, but as you saw this year, which is Tropical Storm Arthur, we get lots of storms that tend to form in May. So if you said A, May through November, sometimes I think that feels more right lately. But officially, the correct answer is C. So way to go to everybody that said either A or C. Now, hurricane season is officially half the year. And you might be thinking, well, okay, it's not always that busy when it comes to hurricanes. Well, let me show you how busy it can get during the peak of the season. The picture you see here is from one day in September. This is September 11th, 2018. And I want to show you how many weather systems were out there at just one time. The big one was Hurricane Florence, the one I'm circling here. That was a Category 4 hurricane that went on to strike the United States, the southeast coast. The one behind it was Tropical Storm Isaac that went on to move across the Caribbean Sea. Behind that was Hurricane Helene. That was a pretty strong hurricane, Category 2, that recurved out over the Atlantic and actually affected Europe. Behind that, we had another tropical storm that went on to become Joyce, and yet another disturbance weather system we were tracking that struck Texas and Louisiana, but not quite as a tropical storm. So it can get really busy, and I can hope that this year won't be this busy, but I have a hunch every hurricane season gets kind of busy like this at some point in time. All right, so you might be wondering, okay, well, when does it get that busy? We'll take a look at what we call climatology and this campfire looking graphic with me. Now, whether you look at the yellow area, which is hurricanes on their own, or the red area, which is hurricanes and tropical storms together, you basically get the same answer, that the peak in the season occurs right here in the middle of September, pretty close to September 10th. And the bottom line for everyone listening is there's 3 months of the year that we want you to be the most ready. And those 3 months we have listed here, August, September, and October. That's when we typically see the most amount of hurricanes. So don't be too surprised if you don't hear a lot about hurricanes in June or even July, because the late summer and the fall months is when it typically gets really busy when it comes to these storms. All right, let's do another quiz. Now for this one, everybody, we are not going to open the poll, so you won't see a pop-up appear on your screen. Let's just read the question together, and then I want you in your homes today to just scream out the right answer. Or if your parents or whoever you're with is telling you to be quiet, maybe then just whisper. You ready for the second quiz? Here we go. What are the primary hurricane hazards or bad weather conditions? Do you think the right answer is A, high winds, B, storm surge, C, heavy rainfall and all the flooding, D, dangerous surf along the beaches, or do you think it's E, all of those? Now I'm going to give you just a second. The correct answer is it's E, all of the above. Way to go if that's what you were thinking. But the bottom line, everybody, is anything you selected here wasn't wrong. Hurricanes, though, deliver a whole bunch of these hazards. And you might be saying, well, how can I remember all of these hazards? There's so much to keep in mind and remember. Well, we get that. There's a lot to remember. So we came up with a word to help you remember these hurricane hazards. The word's called SWIFT, where each letter in the word goes with a different hazard. The S in the word SWIFT, we want you to remember, stands for storm surge, which, as you'll learn from Andy coming up, is a big deal. But for now, just know that storm surge is the water that's over the ocean or in lakes that gets pushed by the hurricane strong winds into neighborhoods where we all live. And more information on storm surge is coming. The W in the word SWIFT stands for wind, of course. It's windy in hurricanes. You already probably knew that. The I and the F in the word SWIFT stands for inland flooding, which could be a really big deal for some locations. And the T stands for tornadoes. Yeah, there could even be tornadoes and hurricanes like we mentioned earlier, especially in some of those rain bands and in certain situations. Let's do another quiz. Everybody ready for that? Oh, before that, I also want you to remember the waves and rip currents, especially if you live close to the beach. A hurricane can produce tremendously big waves, even if one is not that close to your area. So remember to always stay away from the beaches when the meteorologists in your area tell you to do so. All right, let's do another quiz, and I think this is your last one. Now, this one is a poll question, so you will see that pop-up appear just like the first time. And this one's a little tougher, so good luck. Here's the quiz. Which hurricane hazard has caused the most deaths in the United States? Do you think the right answer is A, wind, B, storm surge, C, flooding from the heavy rains, or D, tornadoes? All right, I see Dan has opened the poll. Good luck, and from here, I'm gonna pass it to Andy.
Thanks, John. A lot of folks are answering the poll. It's a really tight race here between a few of the answers. We've seen that in some of our past webinars as well. Give it another few seconds to let all the votes come in. Looks like I've got most of the votes in now, so I'm going to close that poll. And this was a very, very close race between flooding, got 33%, just barely inched out storm surge with 32%, tornadoes with 26%, and wind with just 9%. So let me turn it over to Andy, who's going to share the answer.
All right, thank you, Dan. Yes, it was a really tight race between the two. You guys are on the right track, though. The correct answer is going to be storm surge, believe it or not. Now, when I was growing up, I lived a few miles inland and I lived about 20 feet above sea level. So when a storm came, I had to worry mostly about the wind, and wind is very prolific, very damaging. Look at these pictures of what the wind can do to a building from a hurricane. It can take buildings apart. It can take a 2x4 and put it through a tree if the winds are strong enough. So a lot of people think about the wind. They see that on the news and everything. And water is really what people don't think about but should. And you guys are smart. You're on the right track because the top left-hand corner is a picture of flooding related to rainfall. bottom left-hand corner is flooding related to storm surge, where the water from the sea moves inland. And I'm going to go into more details about that here in a minute. So people don't think about water, but really should, because water is what kills. The answer is storm surge, because nearly half of the fatalities from tropical cyclones come from storm surge. About a quarter of them come from flooding due to rainfall. And there's other smaller percentages due to water-related fatalities are offshore, like if a boat capsizes, or as John was mentioning, rip currents can cause fatalities. But wind and tornadoes are still on this chart. They are very dangerous and very deadly. So we talk about storm surge. We're talking about the water that's moving in from the ocean or the Gulf into areas that are normally dry when the storm moves inland. We have all this force from the wind. This water has to go somewhere, and it pushes inland when the storm moves inland. So here's Manhattan on a normal dry day. Now, Hurricane Sandy, if you can recall, was a very large storm. It actually started in the Caribbean Sea and moved up and ended up hitting New England. So this is what East Village of Manhattan, New York looks like. People were walking around, cars were driving around. When the storm made landfall, you can see the water on this building is at least a few feet deep. This car is mostly inundated by water. And this is all ocean waters, or the waters from the bays and inlets of the area, all getting pushed inland. So what makes storm surge so dangerous? You say, okay, well, I could be hidden up in the building and be okay. Well, that could be the case in this situation. But if you live in areas that are vulnerable to storm surge, and you're in an evacuation zone, when this water moves inland, it's very powerful. Picture yourself at the beach and you're standing in the water a few feet deep and you get hit by a wave that's a few feet high. That can easily knock you over. Well, imagine if water several feet deep is moving inland along with some waves that can easily take homes off their foundations. They can make homes crumble. That's what you see in this picture here of what can happen from storm surge. And this is from Sandy, which at the time of landfall was a Category 1 hurricane. So what's dangerous about this is if folks do not evacuate, when they live in an evacuation zone for storm surge, you put yourself at risk to be stuck in these homes when the water arrives and you will have nowhere to go. Same kind of threat happens from flooding rainfall, where we have very heavy rainfall, and it doesn't even have to be a hurricane. This example I'm going to show you is from a tropical storm back in 2001 in Houston. So you have very heavy rainfalls, and normally the water runs off to the ditches and to the lakes, but if they get overwhelmed from the heavy rain, the water has to go somewhere else. And in this case, in this particular event was Interstate 10, where this water is at least several feet deep along this interstate corridor. Well, what could happen is, as far as fatalities could occur, it could occur here in this interstate corridor, but it also could occur in homes in the area if you live in a flood-prone area. So it's important to know if you live in that sort of area and to keep tabs of what your risk is, especially when there's a storm approaching, and whether or not you should evacuate. And John also mentioned tornadoes, waterspouts. Yes, they can occur during hurricanes. A lot of times you see these outer rain bands as hurricanes approaching, and those can spawn tornadoes. They can also spawn waterspouts. Well, what are the difference between the two? It's simple. Waterspouts are over the water, tornadoes are over land. And yes, tornadoes can become waterspouts and vice versa. The picture on the right you're seeing here, the tornado or a waterspout is moving on land and becoming a tornado. Waves and rip currents is a unique hazard, as John was alluding to, in that we could have a hurricane on your particular location. There could be a hurricane 300 miles away from you. It could be a sunny day. That storm might not even be coming to hit you. You could be at the beach and you could have very dangerous rip currents and very large waves associated. Picture throwing a large rock in a lake. It creates ripples. A hurricane does the same thing. These waves will eventually reach the coastline, creating these large waves. And this wave action, as the water hits the coast and the waves move back, and every few seconds you have a new wave, can cause these erosions that you can see at the bottom left-hand corner of your screen there, erosions in like the sandbar area that you would normally stand in at the beach. And when the water recedes, you can get pulled out to the ocean. And that's why it's so dangerous. It's a very, very bad drowning hazard when there's storms well offshore. And so there's ways to escape these rip currents, including swimming parallel to the shore. And also what you can do is the local forecast, your local weather office might give you updates. For example, the weather forecast offices in the United States send a rip current statement out if there's hazards. Your local office might do something similar And in some of the cases at the beaches, they might have flags to let you know that there's hazards there, even though it might be a bright and sunny day. So we talk about all these hazards. Well, how do we predict them? How do we know how big the storm's going to be, where it's going to go, and when? Well, we first start off with observations. We have a lot of observations coming into the Hurricane Center constantly. We have surface observations from land areas that transmit wind, temperature data, and so on. We have ships that also send similar data to us, and buoys in the ocean that do the same thing as well. We have upper air data from weather balloons that are launched across the United States and other locations around the area, and that can transmit data to us to give us an idea of what the upper atmosphere is doing. Aircraft can fly into these storms, and I'm going to have someone talk to you here about that in just a moment. And that data also is very useful in trying to dissect what's happening inside the storm and in the storm environment. John showed you satellite loop of Harvey earlier. Those are very important instruments. Those satellites in outer space are taking very frequent screenshots or images, photographs of the storm. The bottom left-hand picture here shows an example from zoomed out. We can see what the storm structure is doing on the outside, where it's going, and even try to estimate how strong it is just by satellite images alone. And if the storm's near the coast, we have Doppler weather radar that can send a signal into the storm to try to determine how strong and what the structure of the storm looks like. And we can even try to depict where the tornadoes might be forming as the storm moves inland. Most of this information all gets pulled into these very sophisticated computers models on supercomputers. And there's a bunch of different types of computer models, but they all try to simulate where the storm's going to go, how big it's going to be, how strong it's going to be. Our job at the Hurricane Center is to look at this data, tell what's relevant and what's the good data, what's the bad data, and what's important to determine how strong the storm is going to be. And look at what the computer models are trying to simulate. Are they picking up on the right steering flows to steer the storm one way or the other? Are they picking up on the right ingredients, such as wind shear or sea surface temperatures, making sure those are accurate, so we just try to determine which computer model has the best simulation, most realistic simulation of what's going to happen with this storm. I'm going to hand it over to our Hurricane Hunter visitor so we can discuss for a few minutes about how we fly airplanes into hurricanes.
Thank you, Andy. Hi, everybody. My name is Mike Holmes. I'm a meteorologist and flight director for the Aircraft Operations Center, also known as NOAA's Hurricane Hunters. I live in Lakeland, Florida, and coincidentally, that's where the AOC calls home. And so we will deploy essentially wherever the National Hurricane Center or some other customers want us to go. So we will fly out of Lakeland, and we'll also fly out of other distant locations like Barbados out to the east and as far west as Hawaii and California if needed. We fly two heavy platforms. On your top left of your image, you'll see the first one. It's a Gulfstream 4. It flies at very high altitude, and it's designed to collect data around the periphery of the storm, to sample the environment around the storm, to assess how that environment will affect. And so it provides information to not only the National Hurricane Center, but to the modeling community as well. And the data that it provides comes from drop wind sondes that we release from the aircraft as we fly around the storm. Typically 30 to 45 drop wind sondes are released during a typical mission, which is about 8 hours. The other platform that we fly into storms is the P3. We have two of these platforms. It has a very different mission. It actually flies typically between 5,000 and 10,000 feet and marches right through the storm. What we do is we perform or collect data along these very straight legs. They're typically around 200 miles long, centered on the storm, and we will go in at 5,000 or 10,000 feet and march through the eye wall, mark the center, and then once we mark the center, we will march all the way out the eye wall, again characterizing the storm environment very comprehensively using our in situ instruments, our radars, as well as the drop wind sondes that we release. When we get to the center, that image on the right is what we get to see. This is in a picture taken inside a major hurricane, and as John described earlier, the clouds clear, and we get a great view inside the storm environment. We get to see what's called a stadium effect inside the eye. It's quite beautiful. The last thing I'd like to touch on is we're not the only people that fly inside of these storms. We have some colleagues that fly out of Keesler Air Force Base, the 53rd Weather Reconnaissance Squadron. They have a very large fleet of C-130 aircraft that are configured different than our P-3, but it supports a very similar role. And that is they will march through at a very similar altitude and mark the center and collect data throughout the storm environment and provide that to the Hurricane Center. That's a quick overview, Andy, and I'm looking forward to your questions.
All right, thank you very much, Mike. And this is also a reminder to folks that if you have some questions, we're going to be answering a bunch of them right after this discussion, which is going to end in just a couple of minutes. So start writing it into those question box that we have available for you. Well, how do we tell people about the forecast as the storm is approaching? Well, here you're going to get a glimpse inside the Hurricane Center. The bottom right-hand picture is actually inside our operations area. This pseudo television studio is kind of set up when a storm's approaching, so some of our forecasters and some of the folks that work at the Hurricane Center can give some insight into what the threats and the impact of the storm are going to be. So these cameras are set up and they do numerous television interviews throughout a large storm's approach, pretty much throughout the day and in the evening times. And they try to specify the impacts that these storms can cause for your particular area. And what we also do is we try to get the information out through radio interviews and newspaper interviews as folks call in as well. To get ready for hurricanes, we had a couple weeks ago Hurricane Preparedness Week 2020. This link at the bottom will be shared at the very end, as well as some other good information about where to get the forecast, including our website, hurricanes.gov. But if you need a one-stop shop of where to find all this information, you're asking yourself, am I live in an evacuation area, or what food or what kind of things I need to get ready for hurricane season, you can go to this website. It has a lot of useful information for you. Once again, if you have good questions to ask, go ahead and ask them now. We're going to have a chance for the next 25 minutes or so to answer those for you. And here's some helpful links for you. I'm going to pass it along to Robbie and Dan to start asking those questions.
Hey, thanks, Danny. Great job on all that information. Yeah, we do have a lot of questions coming in now. So I think what we're going to do is we're going to pick out some good ones that we see and throw them to the panelists to try and answer them. And actually, first question I was going to throw to Bob up in Canada. Actually, two different questions. And I think what happened is everybody was looking at the one slide and all the different tools and observations that we use. So Fiorella was asking, what is a RAOB? And Abigail asked, what is a buoy? So I'm wondering if you could describe what RAOBs and buoys are for the kids on the webinar.
Yeah, well, that's thanks, Robbie. And the two different ends of the spectrum there, I guess, in terms of weather observations. The RAOB is essentially data that we get from a weather balloon. So a couple of times a day at various locations around the world, weather folks send up a weather balloon, and then there's a little weather station attached to the weather balloon, and we can get data all the way up to the top of the atmosphere if we're lucky. And so we get information on wind speed, on temperature, on humidity. So we know what the cloud layers are. There's a whole variety of information that we get from that. And then in terms of the buoy is something that's over the ocean, and we know that the oceans it's a lot harder to get data from the ocean because there are only a few ships out there, and there's certainly not as many points of data than there are on land. On land, there's a multitude of surface observations that we can get information from. Over the water, which is actually where the hurricanes develop, there's a lot less information there. So a buoy is basically a weather station that floats. Some actually move with the current, some are actually moored there and they don't really move a whole lot. So those are the two different types of information. The RAOB gives us information about what's going on higher up in the atmosphere, where a buoy tells us what's happening at the surface of the ocean.
Thanks, Bob. Yeah, yesterday I was actually one of the forecasters on duty tracking Tropical Storm Arthur, and was watching some of that buoy observation along with some of the Hurricane Hunter aircraft. Yesterday we had the Air Force Hurricane Hunters in. Mike's, of course, with the NOAA Hurricane Hunters, but I do have some questions for you, Mike, that have come in. Hopefully Rohan's on too. I'll say, Rohan, if you can turn your webcam on a minute, because we might ask some questions to you in a second. But I got one here, a few from Mike that came in while you were speaking. A couple folks, including Aaron and Peter, essentially asking, how dangerous is it to fly into the hurricanes? And then there's one here from Diane asking, how many pilots does it take to fly the aircraft? And then there was another one from Diane, which I thought was interesting because it's a little comical for me, because I, look at the data all the time and know what you were talking about. But she was asking, what do you mean when you collect data along a leg? So it's kind of like your flight path of how you go into the storm. But I'll let you explain those, Mike.
Thanks, Dan. I'll start with I guess I'll go from easy to more challenging, at least challenging in terms of length of discussion. Diane's question about pilots. On both of those heavy platforms, both the G4 that flies high and the P3 that flies lower, we carry a complement of 3 pilots. That keeps a pilot and a co-pilot in the seat at all times, and we also have one in reserve. So one thing I didn't describe to everybody is that these airplanes both fly missions up to 11 hours for the P3, up to 8 to 9 hours for the jet. And so that's a long time for any of our pilots to just sit continually in the seat. So to keep them fresh, we have a 3rd pilot on board. Hope that answers your question, Diane. Aaron and Peter's question about danger. Ironically, the flight meteorologist, the flight director, is in charge of the safety of flight element associated with any hazards with weather. And on the P3, we have a multitude of tools available to us to help us characterize any threats that are in the storm environment. And so when we see a threat, we will alert the pilots, and then we will find a way to mitigate the threat, either go around it, but in many instances, maybe we'll just do an orbit, because we can stay in the storm for many hours at a time. So we can wait out some of these threats. But regardless, we use all the tools available to us to reduce any risks associated with flying in these storms. But one thing's clear: if we ignore Mother Nature's clues about threats, she will cause us harm. And then lastly, regarding the flight path, this is a great discussion item for the National Hurricane Center as well. What we try to do is describe or characterize the whole storm environment. And to do that, we will fly these very long, straight patterns. So for example, we may start at the very north part of the storm, 100 miles from where we think the center is, fly all the way to the south, fix the center, and then once we fix the center, we'll fly another 100 or so miles to the south, and then we'll reposition downwind, cyclonic flow, so that would be off to the southeast, and then we'll do it again from the southeast to the northwest, reposition, and do west to east. And so you kind of get this idea. The storm is circular. We can fly these long straight legs through the storm, and all the while providing data to help describe the storm or answer questions to people like the National Hurricane Center forecasters that want specific information about the storm environment. I hope that answers your question.
Hey, thanks a lot, Mike. Great questions coming in still. I'm seeing a lot of very scientific questions as well, and that's really good to see. Next up, I'm going to pass one to John. John, I think it's our most famous question on these webinars is, how do we name hurricanes? And I think this one's a good one because we've got Rohan and Rohan and Bob on, and it's not just the United States that comes up with these names. So I'll let you take it away to answer that question.
Sure, Robbie. Yeah, and it is a popular question. And here on the screen, you can see the names for the next, from 2020 to 2025. Take a look to see if your name's on the list. Now you'll notice when you look at the names that they rotate from boy, girl, or the other way around depending upon the year. You also may notice that the names have sort of different backgrounds. Some of them are English or American, some of them are more French sounding, some are more Spanish sounding. And here's how it works, everybody. We work through the World Meteorological Organization, which the United States is part of, which Canada is part of, which other countries all across the areas in the Atlantic Basin are part of. And we work together to decide if a storm produced enough damage and enough devastation to then be retired for basically sensitivity purposes. So you may know some hurricanes, sort of probably the ones you're probably going to remember were probably retired. So you can think of storms like a long time ago, like Katrina or like Sandy, or you might think of Irma, for example, retired. And what we do is then we come up with a name to replace that retired storm. But the other ones will repeat every 6 years. So that's more or less how the names work. At the National Hurricane Center, our job is to see if a storm gets a name. It really depends upon if the storm has enough organization and wind speeds of tropical storm force, which are around 40 miles an hour.
Thanks, John. I was going to send the question over to Rohan. We've got folks on from all over, some from the Caribbean, some from Canada and other places really across the world today. Saw some folks from Malaysia and Philippines on even. So, my question to you, Rohan, is besides hurricanes, I mean, the Caribbean, unfortunately, is kind of famous for hurricanes and the fact they get impacted so often. But what other kind of weather hazards do you have to deal with in Jamaica? I know I was there once, and there was a lot of rain that fell, and actually some flash flooding occurred. So maybe you can tell us again what other kind of weather hazards you have to deal with at the office there.
All right. So, for example, from
You're cutting out a little bit, Rohan. Hopefully you'll come back. If not, we can save it for a few minutes until we hopefully get a better connection. Let me save that for a second. And I do have another question I'll send over, and we'll see if we get you back, and also Robbie will come back. But send one over to you, Andy. We've had a couple questions about how hurricanes form. That's been another popular question this morning. So if you can describe exactly what those ingredients we need for formation.
Sure. So there's a lot of different ways storms can form. When we look at the Atlantic Ocean, typically they form from a pre-existing disturbance called a tropical wave. They come off of Africa, they move across the Atlantic, and they get better organized as they cross the ocean. Now, they can come from different things as well. Sometimes they can come from old cold fronts. They can come from upper level low pressure systems. Or just another example from last year, there's a thunderstorm complex that came off from the middle of the United States, moved over the Gulf of Mexico, and became Hurricane Berg. So those are the different ways they can form, but there's certain ingredients they have to be able to form and survive. So a wave might come off of Africa, but it might never develop, or the next wave might come off and become a major hurricane. The difference is the environment. So they, number one, need warm waters, and typically in hurricane season we do have that. But other factors such as wind shear, which is a change in the direction of wind and speed as you go up higher in the atmosphere. If there's strong wind shear, it will blow the tops off the storms, which makes them weaken. Other factors are moisture. If you have a lot of dry air in the area, the storm will have a hard time getting those thunderstorms to develop. And so those ingredients all have to come together with this pre-existing disturbance to make a storm become organized and begin to turn and intensify as it crosses the ocean towards your area. And so you might see a period where you don't have any storms. You might see periods where you have some very intense storms, and that's because you're seeing those ingredients coming together during those intense storm timeframes.
Hey, thanks, Andy. Rohan, are you back with us?
Yeah, I'm back now, man. Right.
Okay. I'll let
So
you
that was
continue answering the question from Dan.
Right. So then I was asking about systems. So let's say from December to about May, we get weather from cold fronts. So the cold air migrates from the north, come across Jamaica, and the difference in the temperature cause showers and thunderstorms to develop. So we have low temperatures as well, and we have thunderstorms occurring, especially across northern Pashes. However, from say May to around November, most of the activity comes from the east, where tropical waves migrating come across the island and they produce heavy showers and thunderstorms. So the morning might start out bright and sunny. You're on the beach, you're having a wonderful day, and then say the tropical wave comes in around 1 o'clock, you have some showers and thunderstorms for about an hour. And then after that, it moves towards the west and we have fair weather conditions again. But tropical waves are the systems that give us most of our activities, especially during the summertime.
Okay, thank you, Rohan. Next question I was going to pass to Bob. So Bob, Preston asked about if you're on a cruise ship and there's a hurricane in the area, what happens? What does the cruise ship do? And I asked this question because both at the Hurricane Center and with you guys up in Environment Canada, we produce marine forecasts as well. So I was wondering if you could discuss how cruise ships and other types of ships out in the ocean get the forecast and how they deal with the forecast when there's a hurricane.
Well, good question. It's a lot of the cruise ship companies have their own weather forecasters that they'll provide information for. If in the event that there's a hurricane in their path, more often than not, they will deviate from that path to get out of harm's way. However, there have been situations in the past where a hurricane has or a cruise ship has inadvertently found itself in some conditions that they probably didn't want to be in. And a case in point was back, there are a couple of cases just a few years ago where a cruise ship got into some bad weather off the mid-Atlantic states. And now with everybody having cameras and video cameras on their phone, we saw some pretty dramatic video of a cruise ship in these large waves. There's another really important case that happened back in 1995 where a cruise ship was coming over from Europe headed towards New York City and ran into some waves that were almost 90 feet high, which was exceptional. We didn't even know at the time that these types of storms could generate waves quite that high. And we got some information from some of the buoys that we were seeing exceptional waves out there, to the point where we actually questioned the data until we got reports from that cruise ship. Now the cruise ship made it into New York City, but not without a fair bit of damage within the ship as well, and there were some injuries as well. That was one of the key storms, one of the key events that showed us that some of these storms, especially when they're accelerating, they're moving faster, can generate some exceptional wave heights out in the open Atlantic.
Thanks, Bob. I'm glad you mentioned that about those big seas, because I think oftentimes people don't think about that, but they can be so devastating for ships. And Rohan, thanks for mentioning those cold fronts in the winter. People don't realize Jamaica gets hit, but I was actually there for my honeymoon a long time ago in January, and that was when we got all that bad weather. It's unfortunate we had a little bit of bad weather when I was there, but it was, again, there was some flooding rains when we were heading back to the airport, but we had some good days too. We had some good days too, so it was a neat place to visit. Mike, I got another question for you about, a couple comments. I see a lot of us on here that don't see any females with us today. So somebody was asking, can there be female hurricane hunters? And I know for a fact that you not only have female hurricane hunters, because we had Nikki on some of our previous webinars, but we also have a lot of pilots. And in fact, I think we had an all-female pilot crew not too long ago. So I know we want to encourage all the young ladies out there too to go into science and meteorology. So I'll let you answer that one, Mike.
Yeah, Dan, thanks. I'm a big advocate for STEM, and yes, we do have, right now we have two female flight directors, both meteorologists, both highly accomplished and amazingly capable, and they're a pleasure to work with. Dan, you've seen the data from them, and of course you've met Nikki on one of the previous seminars. And of course, I think you know Ash from the 53rd. So she's got a lot of experience. So yes, we do have a full complement of scientists in the flight director section, as well as pilots. I would say probably a third of our pilots are female as well, and they come to us from various backgrounds. Some from a military background that flew and came over, mainly from the Navy, some from the Air Force, and then some that are homegrown through NOAA. What I didn't talk about at the Aircraft Operations Center is a whole fleet of smaller airplanes that do other kinds of scientific work, sea mammal surveys, snow ice surveys, and we will bring in brand new pilots, some of them female, and they will grow and develop and ultimately migrate over to the heavies and fly into hurricanes. So that's a long way to answer your question, Dan. Yes, we have female pilots and scientists at the Aircraft Operations Center, and we encourage any young lady to pursue this career field. It's very exciting.
Yeah, thanks. And if you know, folks want to go see, Nikki was on some of our webinars, and we had some female meteorologists with the National Weather Service on many of ours as well. And Robbie will tell you a little bit later in the webinar where you can go see some of those from as well. Robbie, I think you probably have another question to ask.
Yes, I'm here. So John, I think I was going to pass the next one to you. Actually, it's a combo question because I think they're related, and I think the answer you give will show how they're related. But Aaron was asking, why do clouds circle around low pressure areas? And then Terrence asked, what is the Coriolis force? So I suspect you're going to tell us there's a similarity in those questions.
Yeah, there certainly is, and a good question. You know, my daughter actually asked that question. She says, "Why do the clouds go that way?" Or what she's talking about is why do they go counterclockwise in that way? Has everything to do with the Coriolis force. Now, here's how it works in the northern hemisphere, which I think most people are listening to from today, but I can't be sure. So low pressure systems. When we say low pressure systems, it means that the pressure in the atmosphere that we feel is lower. And it usually means it corresponds or connects to stormier weather. Now, hurricanes, since we've been talking a lot about hurricanes, have really low pressure, and that usually is that's part of why we get such strong winds. Now, the low pressure systems in the northern hemisphere do spin counterclockwise, and it has everything to do with that Coriolis force. Now, if you live really close to the equator, like if you live down like in Central America or in South America, then there's a lot less Coriolis force there. And you may notice that you probably don't get many hurricanes the farther south you get close to the equator. But as you start to head north, the Coriolis force gets stronger, and it continues to get stronger even as you get all the way up toward where Bob is in Canada, and you get much more rotation in that counterclockwise fashion. So yeah, it has everything to do with sort of the Earth's rotation and that Coriolis force and how it works. Last thing I'll say is if you live in the southern hemisphere, or if you go to the southern hemisphere, then you have to turn your head upside down because everything works the opposite way, where those low pressure systems actually spin clockwise instead of counterclockwise.
Thanks, John. A couple of folks I've seen, I think Erin earlier commented that her brother was interested in becoming a meteorologist, and I see another one here from Peter that ask, what courses have you taken to become meteorologist? He says he has a dream to become one, but sometimes his family is not sure it's the most practical thing. And I would say you got to go for it, Peter. I think we all did. If you really enjoy weather, science, then I would absolutely say, let's make it your career. I was going to send it over to Andy first, maybe talk about his college experience, what he took. And then maybe Rohan can add a little bit about some of his background as well. So let me send it over to Andy first.
Sure, thanks, Dan. So I graduated with a degree from Florida State University. Actually, we're talking about women meteorologists. My wife also went to Florida State and graduated with a meteorology degree. So I ended up getting my master's degree in meteorology and focused a little bit on some of the tropical weather aspects of meteorology when I did so. To get a job in the National Weather Service, you need a bachelor's degree. And a lot of folks nowadays, though, do have the master's degree, which helps you get a job in the Weather Service. So it's more than just atmospheric science, and I'm going to pass this along to other folks in the panel to talk about. But it's more than just the science and the physics and the math. There's a lot of that in there, but there's other aspects to meteorology as well. If anybody else wants to chime in and elaborate on that.
You might be on mute, Rohan. I was as well. While we're waiting see if Rohan can unmute. Anybody else have anything to add? If John, you look like you're going to answer too.
Yeah, I just want to say one thing to Peter. My family said the same thing, Peter, that it wouldn't be practical to be a meteorologist. My dad had a business, which was a lot of construction and painting, and I didn't want to do that. And he says, oh, being a meteorologist isn't practical. It's going to be hard to find a job, but I didn't listen, and it turned out just fine. So I say you do the same. That'd be my advice.
And I had the same situation as well. But as a child, I used to watch somebody doing the weather on television, the meteorologist, and I said, hey, I want to do the weather on television. So in Jamaica, after you do your A-levels or your sixth form, there's only one place in the Caribbean that does meteorology, and it's the University of the West Indies, and that's in Cave Hill, Barbados. So I had to leave Jamaica, go to Barbados. It's a 3-year course in meteorology and mathematics, and I did my meteorology and mathematics in Barbados. A wonderful experience, and now I'm loving what I'm doing, helping to warn people of the dangers of hurricanes.
Okay, thanks everybody. I think we're almost out of time, but I was going to ask one more question. And because we're coming off the heels of a busy hurricane season last year, we had to get ready for the one that's coming up starting June 1st. John, I was going to let you finish off with this question. Eva was asking, how bad was Hurricane Dorian? Remember, Dorian hit the Bahamas last year. So a lot of people from the Bahamas are watching us today, and I just thought maybe you could just explain to everybody. You wrote the report, the post-storm report that the Hurricane Center puts out. Helped write some of that. So wondering if you could explain how bad was the storm really?
Dorian was terrible, Robbie, but it all depends upon where you live specifically. So Dorian was a very powerful, you probably remember Category 5, remember that scale, the top of the scale. But those Category 5 winds occurred in the northernmost Bahamas. So if you're listening from Great Abaco Island or Grand Bahama Island, yeah, it was very awful, especially because it was so strong and so slow moving. So you had all those winds, storm surge that we talked about, and heavy rains just sort of sitting over the same locations. But if you weren't in those two islands, then it wasn't quite as bad. But Dorian was awful. But what always comes down to hurricanes is exactly what part of the hurricane did you experience and how did it affect your area. So that's one thing I'll keep in mind is they're all different, and we always have to get ready for the next season, regardless of what happened last year.
Yeah, and then I was wondering if Bob could comment real quick too, because I know that you had some pretty bad effects up in the Maritimes of Canada as well from Dorian.
Yeah, the thing with Dorian here is the storm got bigger as it approached. It wasn't certainly not as strong as it was when it was down in the Bahamas. But what we often see with storms that approach the northern latitudes is that they actually get bigger in size, and this was the fact with what we saw with Dorian. A lot of the damage was very similar to what we had from Hurricane Juan back in 2003, which a lot of people remember. And I think, John, you had a picture of Hurricane Juan on one of your slides there earlier. The difference was that the damage was way more widespread. Almost a very large proportion of the province of Nova Scotia was without power for a certain amount of time. The storm also affected parts of New Brunswick and Prince Edward Island, and certainly up into Newfoundland and Labrador and Quebec as well. So a lot of Eastern Canada was affected by Dorian in a really negative way last September.
Sorry for being a little delayed there, getting back on. It looks like we're about out of time. We've gone a little bit over, but again, want to thank everyone for asking all those fantastic questions. Hopefully you learned a little bit about, again, not just what happens at the Hurricane Center, but how we get the data from the folks like Mike and the folks that fly into the planes, and then you know, people like Bob and Rohan that are in the individual countries that are helping to warn residents, again, not just the United States, but across the Caribbean, Canada, Mexico, and other parts of the world. So we really appreciate everyone being on today. I'm actually going to, I think, close the camera. If Robbie's still there, let him come back on and do the final wrap, because he'll tell you where you can find all the recordings of all the various webinars. And again, thanks. So I have to share, I did get a response back from Peter that basically said just how pumped up he was with us answering that question. And we'll take our advice to try to head toward a career in meteorology. So that's awesome, Peter. You go for that. And I'm going to turn it now back over to Robbie for a second.
Hey, thanks, Dan. Yeah, so again, thanks everybody for joining us today. Refer back to the slide you see there on your screen. On the very bottom is a link for the National Hurricane Center's YouTube channel. It's www.youtube.com/NWSNHC. We'll be putting the recording for this webinar onto the YouTube channel, probably later today or tomorrow. We also have a whole host of other webinars that we've conducted within this series. So you can go back and watch some of the others, including some of the ones we talked about with like Nikki Hathaway from AOC, so you can see some of the women that we work with as well. So please take a look when you get a chance. And everybody get ready for hurricane season. We've already had a preseason storm with Arthur, and we know that we're probably just going to ramp up from here, unfortunately. So again, thanks again for joining us. I want to thank all of our panelists, Bob, Rohan, and Mike, for joining us today. It was great to have your experience and expertise in the realm of hurricanes. So I'll just say goodbye, and everybody stay safe, stay healthy, and have a great day.